Okay. Make sure everything's fine. Right. Okay, it looks like everything is fine. Here's your IGCSE chemistry. Can you quickly write May and okay 19 May 2026. We start with chemistry, and then after 30 minutes we will do physics. Are we together? Guys, are we together? Okay, so let's quickly go through it as fast as we can. Right, 19 May, we're going here. Let's look at the structure of the chemistry. We know that chemistry is 12 topics. Now, of these 12 topics, I want to help you master the things that I know that right now in class you're probably doing. So I know that the things that you are probably doing, you people do different chapters because you're at different schools. But there is stoichiometry. There is electrochemistry. There is 5 chemical energetics. Chemical energetics is where you do endothermic and exothermic reactions. Is there anyone who has done this yet? And oh, that's great. That's great. So I'm going to quickly explain to you what you need to know there. I'm going to quickly explain to you what you need to know. Who is doing rate of reactions? Chemical reactions, this is chapter 6. Who's doing it? Rate of reactions, or who is doing redox reactions, oxidation, reduction reactions? Oh, okay. Wow, that's good. Who is doing um who is doing 7, which is well, let me get Millicent back. Something happened to her. Okay, we are still live. Who is doing um who is doing acids and bases? Acids, bases, and salts. Anyone? Who's doing acids, bases, and salts? Nobody. Who is doing the periodic table? Who's doing metals? Is there anyone who's doing metals at school? Oh, really? Okay. So 8 is the periodic table, then 9 is metals. So I know from experience that a lot of you are in this section of chemistry, like I've just proved to you. Amanda, which one are you doing here at your school? Oh, okay. So you're doing chapter 4. This is Amanda. Who was doing chemical energetics? Is it Ilang? Oh, it's Lenny. Ilang, you're doing rate of reactions, right? Okay. And then metals, this is Litabo. Oh, okay. Right. Okay, so here, this is what you do. These are the things I'm going to be covering. So I'm going to be covering these topics so that all of you are good at these ones. I'm going to make sure you know the important things that you need to know for this. Are you all ready? All right, so I'll start with topic 7, acids, bases, and salts, and then I'm going to move back and forth with all these other topics. We'll be moving extremely fast. So in class, I want you to write the notes as fast as you can. You are a very, very important group, and I'm going to be using you to do very important topics. You hear me? So we are doing, we know that there are 12 topics, but we are focusing on topics 3 up to 9. Okay, because those are the ones you're covering right now at the stage you are at school. Do you understand why I'm doing it? Do you understand? Girls, do you all understand? Are we together? Yes, Amanda, you didn't understand. What, you can ask me. What is the question? Oh, why don't we start from topic? It's pretty much the same thing. I mean, okay, we could start. Let me explain topic 4 to people, so you can understand it. I'm just trying to get Millicent back in. I think it's a power cut, because that's what affected me yesterday. Okay, let's do it. Amanda, you want to start with topic 4? It's like the same thing. We could still do that. We could start with topic 4 and then we do the next, the next, the next. Should we do that? Is that what you guys want? What would you guys rather have? Topic 4 or topic 7? Can you raise your hands? We're still gonna do all of them, 3 up to 9. I mean, we kind of did 3. We'll do all the others. Can you show by raising? Good. Millicent. Millicent, which topic are you doing at your school right now? Oh, she's doing topic 7. Oh, oh, you already did the periodic table? Okay. Oh, good. So you see, everybody. So I'm going to cover all of them real quick. To be honest, Amanda, by the end of this week, we would have done topic 4 also. Okay? I just assets based and sort is going to give you a lot of things that will be very important. And the topic of metals also, it gives you something which is very important for topic number 4. So to be good at topic number 4, you need topic 2, topic 9, a little bit of topic 7. Yeah, it's not so important, but yeah. I'm just going to start with topic 7, but I'll do topic 4 before the end of the week. So just write with me to say 7 acids, bases, and salts. Okay? Then we're going to be going back and forth and we do all the topics. So acids, bases, and salts. There's a lot of experience that I want you to have by the end of the lesson. I want to train you people something which is going to be very important that I think you're going to use for the rest of the thing. Okay, that I think you're going to use for the rest of the of your studies. Anytime you're going to be doing your studies, you're going to be using something very important that I'm going to teach you, and it is how do you ignore things that are very small and focus on the main ideas. So I'm not going to explain too much. Let me say this topic. Right with me. This topic is broken down. This topic is broken down into 2 parts. This topic is broken down into 2 parts. One is going to be characteristics or properties of acids. Then 2 is going to be preparation of salts. This is actually the main thing you must be able to do. Preparation of salts. So we're going to look at this. When we are done with that, then you know you are done with the topic of acids and bases. Are we together? Right. Good. So we start with 1. And I want you to say properties of acids. Properties of acids. This is the first one we are going to be covering together. Properties of acids. And right, say by the end of this section, you must be able to understand several concepts, or you must already understand several concepts, which are: one, the pH scale. You must know what neutralization means. You must know what the acid reactions are. You must know how to name salts. You must know a strong acid versus a weak acid. You must understand the word concentrated versus the word dilute for acids. Okay? Are we together? You must know the difference between H plus and OH, or you must know both of them, H plus and OH minus ions. You must know the universal indicator and its colors. Okay? You must know oxides. Okay? You must be able to classifying oxides. You must be able to separate them, distinguish between the oxides. And you must know what amphoteric oxides are. Can you see all this? And you must understand in acids what do we mean by proton transfer. You must understand what do we mean by ionic equations. So these are small things that I'll need you to understand. And you must understand acid plus carbonate. What do you get? Okay? The reactions of acids and carbonates. And you must know, lastly, ammonium ion. So there's quite a lot of things to know. We're going to cover them as notes. I'll be giving you as notes. And as we are doing them, you'll be able to understand all these different things as I give it to you as notes. Are we together? All these different things, you must be able to explain to me what they are through the notes I would have given you. Are you ready? It's not too much. Okay? So this is that section 1, the properties of acids, say, and bases. Properties of acids and bases. That's the section we are doing. Are you ready? So right to say, this whole section teaches the general characteristics. The whole section teaches the general characteristics of acids and bases, or you can say the general characteristics and reactions of acids and bases. So we just want to know the characteristics of acids and bases and their reactions. That's what this section is about. Are we together? Okay. Start with the first thing. Part 1. Say the preparation, or I just want to say the properties of acids. Put this as the first thing. The properties of acids. Can you all do it? understand the properties of acids. Right. And I'm going to be moving quite fast to just get you to know the main ideas and the most important things, and you'll be done, okay? Good. What is an acid? Must clarify. How do they define an acid? What is it that chemists saw and they called it an acid? What was it? So write with me. Let's go. We use the properties. We tell you what an acid is using the properties. Okay? There are other definitions, the Arrhenius definition, the what, but here are the things that you should know about anything that is called an acid. So you say, acids are chemicals that have pH values below 7. That have pH values below 7. Okay? They are also sour. They're also sour in taste. Although you mustn't taste some strong acids, they'll damage you. And corrosive. And corrosive in nature. We're going to work more about this, okay? Where you're going to be studying metals, and then we're going to understand what the word corrosion means, okay? We're going to study more in chemistry and this. But when we are talking about corrosion, it is just reducing value. It's when something reduces its value to deteriorate. And it usually happens to metals, so that's why you're going to study more, okay? So reduce in value. You understand? Like rusting. It's a type of corrosion. Are we together? There are other things like where you have silver, a nice beautiful silver, then you start having black spots forming on it. That's another type of corrosion. But when you just say something is corroding, just know that it's not good. Okay? It's not good. It's losing value. It's degrading. Okay? So it's when something becomes undesirable, it reduces. So let me say degrading. Okay? Degradation. Reduce in value. Okay? So acids cause things to reduce in value. Are we together? Acids also, so these are always that you can tell that, oh, this is an acid. Most important one is that they have pH values below 7. Acids also produce hydrogen ions. Acids also produce hydrogen ions, which is H plus ions in water. When you put anything that we call an acid into water, it should put H plus ions in that water. Okay? Finally, acids neutralize bases. Neutralize bases. In other words, you take something that has the properties of a base. If you add an acid, those properties will go. Do you understand? Yes. Okay. So they neutralize bases. But do not forget that acids are going to produce H plus ions in water. So if we want to keep going with them, we are going to say, okay, let's know about them. You say acids in water. Let's see what happens from a chemistry perspective. What happens? You're going to have your acid, then it is going to go into water. When you say aqueous, it means it dissolves into water. It is going to separate. H plus. This is an example of an acid, hydrochloric acid, plus CO minus. You know that all acids have hydrogen. So when they go into water, they're going to separate. And the hydrogen will become an H plus ion. And that is why we say all acids produce H plus ions in water. Okay? Because they have a hydrogen, which is going to separate when it goes into water. it will separate and become an H plus. So if you want to know this is an acid, you should test for H plus ions in the solution. Do you understand? Okay, this is an example. So this is an example of an acid in water. And we can keep going. To the third thing, we deal with acids. Okay, or you can say reaction of acid plus metal. Reaction between an acid and a metal. You must know, what do you get when you react an acid and a metal? These are just things you must know. We're just looking at the properties of acids. Okay? Are we together? When acids react, we know that when they go into water, they release H plus ions. So we can say they produce H plus ions or they release H plus ions in water, because they have, when acids react with metals, they form a salt and hydrogen gas. They form a salt and hydrogen gas. Okay? Are we together? So you can say acid plus metal gives salt plus hydrogen gas, which is a fuel. So acid plus metal, this is what you get. You don't have to put are you seeing? And what will be happening is, here is what happens in your acid. The metal takes the hydrogen to become a salt. It takes the other element to become a salt and leaves the hydrogen to stay on the lawn all the time. So if I have HCl reacting with sodium, then what I'm going to have is Na takes this nonmetal and becomes the salt. Salt is just an ionic compound. Metal takes the non-metal here. It becomes a salt, which means an ionic compound. Plus the hydrogen is released. And that's how we have. Are you seeing? Yes. So here, this will be a chloride. That's the type of salt. I want you to understand what salt means. Here you get your hydrogen. If we can say 2 of these, and you say 2 of this to form 2 of this plus H2 gas. Okay? Are you understanding? Yes. Right. And I want you to know that only metals that are above hydrogen okay, only metals that are above hydrogen react with dilute acids. Okay? Can you all see? Okay. Now, what you should then be able to do when you do this is you must be able to name, because they want you to be able to name these salts. You must be able to name the salt that you get when you react an acid, and a metal. You should know what type of salt do you get. Now, the salts let me give you some that I feel you must know. Okay? Let's say you take sulfuric acids. Sulfuric acid H2SO4. All acids have hydrogens. You react with any metal. You react with magnesium. Then obviously, what happens? Tell me. Acid, when it meets a metal, what happens? It throws away the hydrogen, right? This part will react with the metal. So you now have Mg, then SO4. Then the hydrogen will go alone. Can you see? And what makes it easy is Mg is from group 2, so it's a 2 plus. SO4 is a 2 minus. So they'll get in nicely and it's like that. Right? This now is called nitric. Pardon? Yes. Okay, only metals that are above hydrogen in the reactivity series. In the reactivity series. So I'm going to have to teach you. I'll teach you, okay? The reactivity series. You're going to do it when you do metals. When you learn about metals, you have to know the reactivity series. And you're going to use it in chapter 4 as well when you're now doing electrolysis. Okay? Yes. So there's a list. Reactivity series is a list of all the metals according to their whatever. So don't forget, the important acids we have, this is hydrochloric acid, this is sulfuric acid, this is nitric acid. Nitric acid, if it meets something like magnesium, what would happen here is this NO3 would bond with this Mg. So it becomes MgNO3. Then this hydrogen now will come standalone. Can you see? The hydrogen will stand alone. Now, because hydrogen cannot be alone, it should always be in pairs. We need 2, so everything is going to be 2, then 2, then 2. Are we together? Yes. Now, what you'll be now doing is, you should know that for MgNO3, it's like this. Here, you can say it's 2, then you can put the 2 here. This is where the 2 actually is. For MgNO3, you don't need to put 2 here. It'll be 1 Mg, 1 Mg. Are you seeing? Have you written it down? Okay. So what have you learned so far? We've seen that here are common acids that we are seeing. We have HCl, we have H2SO4, we have HNO3. This is hydrochloric acid, this is sulfuric acid, this is nitric acid. Right. What we are seeing is that acids will react with any metal that is above hydrogen in the reactivity series and give you what? Salt plus hydrogen. Hydrogen is always released. You need to show it being released. Okay? That's the one reaction I've given you. And I've also showed you what happens when an acid goes into water. It separates like this. I used an example of HCl. Okay? Good. This is hydrochloric acid so this H2SO4 will be this. I want you to write sulfuric acid. Then here I want you to write nitric acid. Okay, these are three typical examples of acids. Are we together? So can you confidently say you know what happens when an acid meets a metal? Is there anyone who still doesn't? Right. Can we move on? Okay. Now let's do the second reaction. Write with me. Acid plus base. And in brackets say in brackets, you write it like this. Write neutralization reaction. Have you written it? And I want you to know that when they say base, I'm giving you a tip, they mean hydroxides, okay? And some oxides, but mostly the bases are just the hydroxides. Are we together? The hydroxides are just your bases, okay? Now, what you must know is that when an acid meets a hydroxide, I'm telling you, it's my tip. It's the base, so they say acid plus base to give salt plus water. Okay? What I want you to know now is that metal hydroxides, we already said, we already expect anything that ends with OH is a base. Metal hydroxides and also oxides. Okay? And metal here and metal oxides are the bases. So when they're saying you're doing acids and bases, which ones are the bases class? Which ones are the bases? Yes, let's put examples. E.g., KOH. This is potassium hydroxide. NaOH. This is sodium hydroxide. Can you see all these? MgOH. This is another hydroxide. Give me a second. Yes. Can you all still hear me? Yes. So I want you to be very good, knowing that when they say base, they just mean things that end with OH and things that end with O. Potassium oxide, it's like this, K2O. Sodium oxide is Na2O. Magnesium oxide is MgO. These things are ending with O. Oh, which means they are bases. So these are the bases. When they react with acids, here are nice acids: hydrochloric acid, sulfuric acid, nitric acid. Phosphoric acid is H3PO4. For most acids, the hydrogen is quiet, so it's sulfuric acid, nitric acid, phosphoric acid. You skip the H. Can you see? These are all acids. Can you see them? And we know that when an acid meets a base, and we know that when you say base, you mean hydroxide or oxide, we are going to get a salt. What is a salt? Students, what did I say a salt is? An ionic compound, right? A salt just means you now have the metal and the non-metal together, right? Then instead of getting hydrogen, you get water. Acid plus base gives you salt plus water. So let's do an example. HCl meets KOH. What's going to happen? Students? HCl meets KOH. What's going to happen? We know that all the time acids will sacrifice their H. Now, bases will sacrifice their OH. Okay? Bases will, because they have it, they will sacrifice it. So what will end up happening is the K will meet the Cl. That happens every time to get the salt. So it's potassium chloride. Plus the H plus and OH minus will get H2O. Right? Are you see? This is your salt. This is your water. Don't let me down now. Don't let me down. Because you know what you are going to get when you react an acid with a metal? You know what you get when you react an acid with a base? This is called a neutralization reaction. Can you see? I want you to write here to say neutralization. But can you see this? What a neutralization is? Have you written it down? Right. Write one more reaction. Was this part D? Here's what I need you to write. This was 3. This was 4. 5. think of a new crane. Now I want you to say acids plus metal carbonate. Acids plus metal carbonate. You can all hear me nicely, right? This is the last one. Okay. So this is so important. Acid and metal carbonate. Are you ready? Write it like this. Acid plus metal carbonate. In the question, you'll be given a metal carbonate in the answer. So you should know acid plus metal carbonate gives salt plus water plus carbon dioxide. So to be honest, a carbonate is just like a base. It produces salt and water, but here is what makes it different is that there is carbon dioxide. Salt and water is going to be the same. So if you take an example, okay, let me think of a carbonate. I can give you magnesium carbonate. It will react with acid. What do you think happens here? Here, the metal is here in the carbonate. Here, Mg will react with Cl. It can't touch the hydrogen. The metal never touches the hydrogen. You'll be wrong. And it needs two of them, okay? Because it's from group 2. Are we together? Then, what happens? MgCl, you now will have what? The carbon. But you put it at the end. First, you put your water. Then you put the carbons. So here, can you see? Yes, that is very important. Don't forget here. If you get magnesium carbonate like this, it will give you this. You can write it as MgCl2 even because it's just a Cl. Then you're going to have water and you're going to have carbon dioxide. Write it down. This is going to be an example. Okay? Write this down. Have you written it down? Can you all try to tell me what you get when you react magnesium carbonate? You react it with nitric acid. What happens? Hmm? Do it, let's see. This is your chance to try. Now, right, tell me what you get. Send me a snap. Show me what you get. Tell me.